Hello friends, welcome back. We are making a Lisp and we're on step 2, evaluation. We've been working on the reader and we've been working on the printer, but we haven't done any eval stuff yet. So this is going to be pretty exciting, I think. We get to actually teach our language how to do some math, add and subtract and multiply and divide. I can't wait. Let's jump right in and see what we can get done in the next little bit. So first step is we're going to copy step 1 read print to step 2 eval. And I've already got the file up here. I'm just going to do a save as and step 2 eval.cpp. And yeah, what's the next step? So we're going to define a simple initial REPL environment. This environment is an associative structure. We're going to use an unordered map, kind of like we did with the hash map in the last video. It maps symbols to numeric functions. Okay, so this is what it would look like if it was Python. And right away we have some problems. We don't have a numeric type yet, so we need to add that. And we don't have a function type yet, so we need to add that. So we've got a little bit of work to do before we can get this part done. So let's jump over to our types and go ahead and make those other types that we want. So an integer value, public value, and it's going to have constructor value. It's going to take a long, and we'll say m long l. That private long m long, and we'll just say it's 0 by default, and we'll have a long too long turn m long. So we'll just have a way of getting the underlying data type back out. Oh, these are not curly braces, of course. And so that's our integer type, and then we also need a function type, and this one's a little more fun. This is a little bit deceiving. Obviously, all the functions in mal don't take 2 parameters. There is, let's see, where was it? Somewhere in here. Here it is. There's a comment. If your target language does not have full variable length argument support, variadic, vararg, splats, yada, 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 then you'll need to pass a full list of arguments as a single parameter and split apart the individual values inside of every mal function. C++ does have variadic function templates, but I think that's going to put us in a whole new category of programming that I just don't want to get into. So I'm going to do what it says. I'm actually going to make it pass an argument count and then a pointer to a bunch of pointers, essentially a count and an array. And I think the way I want to represent that is say, let's say we can have a function pointer, and we'll call it fn putter, and it returns a value star, and it takes a size t and a value star star, and that's going to be our function pointer, and then we need to wrap that in a type. So we're going to say function value public value, like so. Fn value takes a fn pointer, fn m member fn something like that. Fn pointer m fn, and it's a null putter by default. Okay, something like that. And then let's make a way to get it back out. To fn turn m fn. Okay. So we have these 2 types now. We have a way to represent an integer and a way to represent a pointer. And this is also deceiving for the reason that we are going to need a way to tell what type these are. Because we're going to have to static cast. So we're going to get a value star. So right here, it's a pointer to a bunch of value stars. And if they're integers, then we're going to need to static cast them to this integer value type. So we need a little bit more I don't know, some sort of mechanism here to keep track of what our types are. So I think what we'll need is some sort of type enum, and we'll call this a list, and we'll have a bunch of enumerations here: list, vector, hash, map, symbol, integer, and a function. I think that's all of them. I didn't have anything after hash map, right? Hash map, symbol value, function, integer, function value. Okay, why did I put that there? Let's put it right here. And then we need a way to return the type. I'll just do assert 0 here, just kind of a cheap trick, I guess. Let's move that up. And then for this one, we're going to say return type list. And we're just going to go down the line here and add these to all of our types so that we can figure out what we got at runtime. Oh goodness, I just realized I did that all kinds of wrong. Got a little bit happy with my copy paste. Okay, now it's happy. So they were all the way down to here. Symbol value. This is going to be a symbol, and this one's going to be. Oh, I didn't add an inspect here. Integer, and this one's going to be a function. Okay, so we need an inspect as well. So let's copy this down here. I don't really know what order these should go in, but let's do stud toString mlong. So we can get that back out. And then for the function, I'm just going to return something like that. Because I don't even know how to represent a function in our language. So good. So we have a way to check what type it is, but we don't have a way to static cast. I don't want to sprinkle static cast all over the place. So I'm going to do list value star as list. I can't do it inline because I can forward declare these, but I can't do the implementation inline. I don't think. We can try it, but I don't think it actually works. Let's go ahead and forward declare all of these. Ooh, cool. How do I do that? Value hash. Goodness. Slow down. Hash map value, symbol value, integer value, and fn value. Yeah, I don't think I can inline do this because turn static cast list value star this. So I don't think it understands yet that it's related. So I think we'll have to do it in another place. Vector value, hash map value, symbol value, integer value, and fn value. All kinds of things. Integer, symbol, hash map, and vector. Okay. Okay, so over in the CPP file, we're going to paste these in. We're going to say value, oh my goodness, value colon, right, like this. Get rid of that, re-indent that. Okay, and then we're going to do assert that it type is type list and vector and hash map and symbol and integer and function. And then we're going to do return static cast fn value star of this, And we're going to paste these in everywhere. This is going to be an integer value. This one's going to be a symbol value, a hash map value, vector value, and last but not least, list value. Whew. Oh, my fingers. Okay. Now we have a way to static cast that. So we have a way to check what type something is, and we have a way to static cast it to the type that we need without having to sprinkle static casting all over the place. What do we want to do next? Oh, we need a way to read integers. So in our reader, how are we going to do this? I guess I'll do a case 0 here. 1, oh my goodness, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no, oh, I don't want 0 actually. I don't want 0. Because the number can't start with a 0, I think, in Mal. Maybe later, but not for now. And then we want a size t start equals m index, kind of like that. And at the end, we want to, you know, I'm just going to copy this. It's going to look very similar. Except this is going to be the 0 through 9. Oh, I love it when you can copy paste stuff. Okay, so 0 through 9. If it's 0 through 9, then we don't do anything. It's just a break. If it's not a 0 through 9, then we want to say done equals true and break. This will be a plus plus. No. I think this is a plus plus m index. Hopefully I'll get this right here. Character. Let me think about this. So we're looping through, we set the start. This is going to be true the first time through because we haven't moved yet. It's a little bit inefficient, but that's okay. Then we increment the index and we go to the next character. And so let's say it's 90. This is still going to be true, so we increment the index. So now we're 2 ahead. The third time through, it doesn't match. It goes to here, it says done, true, break. We break out of this loop, and we return from the start, and this will be 2. That's a length of 2. Yeah, I think we're good. I think the Lexer will now Lex numbers, integers. No decimals yet, but I think we can do integers, whole numbers. So that's the Lexer. The reader, we're going to need a read integer. I'll go ahead and, oh no, put it right here. Read integer and the reader CPP. So I guess I'll do something similar here. 0. Where's my 0 through 9? Where's my 1 through 9? Just gotta paste that. Read integer. Oops. Read integer, and then we need a read integer function. We need a token, so do this. Not a peek, though. We need to actually consume the token. And then we need to convert it into an actual integer. So right now it's a token, a string view of individual characters, and guess we need to convert it into a number. So we'll start with 0. And I got to remember how to do this. It's been a while. I think we want to do a ranged for loop. We'll do char c over the token. Token, what is token? Oh, it's optional, so I gotta dereference it. And the digit, I mean, I guess that could just be an int, is the character minus something. So let's go look at the ASCII chart. We need to turn ASCII chart. We need to turn our number into an actual number. So 48. So the 0 is going to be 48. So I think we can subtract 48 here. I'm sure there's a library function that'll do this for me. It's okay. Num plus equals digit. And then the second time through, we need to multiply it by 10 because it's all base 10. The second time through. Oh, but I can do it the first time through. Because 0 times 10 is still 0. So I can do it every time. I can multiply by 10 and then add the digit. Ooh, I think that's right. It's been a while, but that might be how you read an integer. Maybe. I guess the way to check that would be to update our make file here. Step 2 to eval, step 2 eval, step 2 eval. I was going to add a clean function here, which I like to use occasionally. And it needs a tab. There we go. Okay, so now we have a clean step. We have a step 2 eval. And we'll make step 2 eval. I should have done this. Step 2 eval 2. 34. Well, either it worked or it's not even getting into this code at all. How can I make sure it is? See out. Yep. If it's getting into this code, then I feel confident that it worked. Yep. Okay. Well, that's pretty cool. Our lexer and our parser now can parse integers. Great. So back over to types and back over to step 2 eval CPP. Where are you at? There you are. So I think we can go back to the guide now. I think we have a way to do all of this stuff. So we want an environment, and I guess the environment could look something like this. Stood unordered map, symbol value for the key, a value star for the value. We'll reuse our hash map hash and hash map pred function objects for the comparators, for the hashing stuff. Do I need to include unordered map? I think I do. So we now have an environment that can hold that stuff, and we need to build it. So say env env new symbol value plus equals new function value add, and we need to go build add. Something returns a value star, add takes a size t arg count, takes a pointer to some pointers, and I'm just going to throw some asserts in here. Arg count is 2, because I'm mimicking what they're doing here. We'll change it in another step probably, but for now we're just going to always accept 2 arguments. And then we'll say auto a is args. Oh, this is args. args 0 and b is args 1. And then I think I'm going to do some assert here as well. A type is value type integer, and b type is that. And then we want to do the addition. I'll say long result equals a, and this is where we're going to use the static cast stuff that we built here, one of these. Oops. We're going to say as integer. So now it's statically cast to an integer type, an integer value type. We're going to say too long plus b as integer too long. And then we're going to return a new integer value with the result. Yeah. I think we did it. I think that's right. So we wrapped our function pointer in a function value so that it walks and talks like a regular mal data type. I think that's right. Now, I've mentioned this before. We're going to have a garbage collector. This is a very dynamic language. Everything's on the heap, even integers. Yeah, that might bother you. There are ways we could do it on the stack, but it's going to make it way more complicated. And I think our goal here is to get a language that works in a decent amount of time. So I do have a video about using smart pointers to kind of like make it a little bit smarter and not heap allocate everything. But this is going to be great for what we're building here. Just kind of like a little toy language. It's totally fine. So I'm not going to do the subtract and multiply and divide because I'm not 100% sure that I did this the way I want it to end up. So I think for now, add is fine. Now we want to modify the rep function to pass the REPL environment as the second parameter for the eval call. So we need to pass this environment in somewhere, and we're going to have to pass it into rep. So we'll pass it in as the second argument. This will be an env reference env, and we need to pass it into eval like so. Eval needs to accept it as well. Env reference env. Okay. And then create a new function eval ast, which takes an ast and the environment, and it switches on the type of ast as follows. Okay, eval ast. So we're going to work on that. Value star eval ast, value star ast env env. Paste, paste. Okay. Let's just format this a little bit just for fun. Just for fun. Otherwise, why am I going to all this trouble? I don't know. Let's just do it like that. Okay, stop fiddling with the content. Switch. If it's a symbol, so AST type. So we're using those type virtual functions again. Case, value type symbol. If it's a symbol, we're going to do something. If it is a list, we're going to do something. And default case, we're going to just return AST. Okay, so let's indent that. We don't need this anymore. Symbol, we're going to look up the symbol in the environment structure and return the value or raise an error. We don't have exceptions yet. I'm not going to worry about exceptions in this video. I'll do it later. So we're going to say auto search is env dot find ast as symbol. If I just pass AST here, it's a value star, so that's going to complain. So I have to statically cast it to a symbol. We know it's a symbol because we checked its type here. I'm going to say if search is env end, then we're going to throw an error. Std c error error AST as symbol. I have a way, what is it, C stir or just stir? Okay. Stir not found. And we'll, do we abort? I'm not going to abort right now. I think that will mess up the REPL. We'll just return new symbol value nil. I think that's wrong, but until I see a failing test, I won't know exactly what to do here. Otherwise, we're going to return search.second. Is it dot second? No, it's a pointer. Okay, so look up the symbol in the environment structure and return the value or raise an error. Okay, so we did this. Return a new list. There's a result of calling eval on each of the members of the list. Okay, not too hard, I think. Results equals new list value. Return result for auto. We're going to call eval on each of the members of the list. So auto val AST as list. I think. Oh, right. I need a way to iterate over lists. So I don't actually. How do I do this? Vector iterator. Is this how you do it? I don't know. Begin. Can I just return mlist.begin? Oh, right. That's not an actual type. Maybe I could use auto here. Ah, that's so beautiful. So now this can iterate over that. Did you mean to dereference it? Why, yes, I did. So this is a value star. And we want to do result push eval val env. I think that's right. So return a new list that is a result of calling eval on each of the members of the list. We're going to call it good. I think I need to, no, that's fine. We'll leave it. We'll leave it there. Okay, let's go back to here. Modify eval to check if the first parameter AST is a list. So we're going to copy this. Eval, the first parameter is a list. Switch on, we're going to call this AST. AST. Okay. AST, let's move this over. Case, AST is not a list. This is not a switch. Sorry. If AST type is not equal to, let's move this up a little bit. Why am I formatting these comments? I don't know. If AST is not a list, value type list, then we're going to do something. Else if AST, we know it's a list at this point, is an empty list, as list is empty, then we're going to do something else, and then the if it is a list, and we already know it's a list, so that's an else. Okay, so we don't have an is empty, so we'll just add that real quick. List value, list value. Bool is empty, return m list size 0. So that should make you happy. So if it's not a list, then return the result of calling eval AST on it. return eval ast env. Oh, I don't have eval ast. So these are mutually, they call each other mutually. Mutually, is that the right word? So I need to forward declare that. So return the result of calling. Yeah. If it's an empty list, return it unchanged. Return ast. If it's a list, call eval ast to get a new evaluated list. Okay. Sure. List equals eval ast env. Take the first item of the evaluated list. Okay. Take the first item of the evaluated list and call it as a function. Should I call it first? I guess first equals list. I'm going to say as list here. I'm just assuming you're a list. You better be a list. List first. Why don't I just do at 0? I don't have an at yet, do I? Value star at size t index return mlist dot at index. So now I have an at. First. Take the first item of the evaluated list and call it as a function. Okay, so you better be a function. Sure hope you are. Sure hope you are a function. Call it as function using the rest of the evaluated list as its arguments. Okay. The rest of the evaluated list as its arguments. Okay. I need like a little array here. Value star args, that's the list size -1. Do I even have size? I don't have size yet. Size, why am I copying? Size t, size, return m list size. For size t, I is 1, I is less than list size. Blech. Okay. Args I, ooh, no. Args I, 1, so this needs to be 0 based. Minus. This feels so error prone, like I'm going to mess it up. List at I. This feels a little gross. If you know a better way to do this, please comment below. I feel like this is going to blow up in my face, but it's the best I got right now. What's the best I got right now? Okay, so call evaluate to get the new evaluated list. Take the first item of the evaluated list, call it as a function using the rest of the evaluated list as its arguments. So first, we're just going to call this function. To function, that's a little bit redundant. There we go. Now we're going to call it turn fn list size -1 because we took the first item off. Pass in the args pointer. Okay. Did I do it? The process of taking a list and invoking or executing it to return something new is known in Lisp as the apply phase. Try some simple expressions. Ooh, are we done? +2, 3. Ooh, I'm really nervous that that I did not do something right here. Plus 2, 3, cross your fingers. That's certainly not what I expected. I don't think the make step actually ran. Make. RM step 2 eval. Was I editing the right file? Okay. Make step 2 eval. Step 2 eval plus 2, 3. Fascinating. What's happening here? Eval AST, eval AST. So we gave it a list. We gave it a list of plus 2 and 3. So that's here. I don't know. Eval AST. Was eval AST... Yeah. Okay. So this is a list. We eval AST on the list, which goes down to here. We eval each item in the list, and we push it onto result, and we return the result. So now each item is evaluated. So the plus should have been a symbol evaluation. Cool. Not sure what I did wrong. Okay, so I just need to add some debugging here. So I'll say symbol AST as symbol stir. And this is a list. Oh, I could have just done inspect. That's fine. Okay. It's up to date. No, it's not. I just changed it. Step 2, eval CPP. Step 2. Oh, there's something wrong with my make file. I bet that's it. Did I do something wrong here? Yes! 2, eval CPP. Oh, I bet you saw that. I bet you saw that when I did it, and you were yelling at your screen. Plus 2, 3, symbol plus, error plus not found. Okay, now we're getting somewhere. Got actual errors. Can get rid of this. So why do we have a error plus not found? Plus not found. Plus not found. Ooh. I think I know what the problem is. Hash map pred right here, where it compares the two keys to see if they are equal. I put a big old fix me here, but I never went back and fixed it. So I'm gonna cheat. I'm gonna leave the fix me. I'm not actually gonna fix it yet because we don't have equality. But I'm just gonna do if the two strings are equal, and that means this can't be const expr anymore. Okay, so let's do rm step 2 eval. It does stuff. It does stuff. 1, 12, and 3. Oh, yes. Okay, so if I do a minus, it gets minus not found. Okay, that throws an error. That's kind of expected, I think. Oh, that's so cool. If I just do a plus by itself, I get that. If I do a minus, I get that. Okay. think we can implement the other ones. Step 2 eval CPP. I think we can implement the subtract and multiply and divide ones now, because this seems correct. Minus. Goodness gracious. I'm so excited I can't even type now. Multiply. Oh, that's so cool. Oh, multiply, and div. We'll definitely have to work on some error handling. But yeah, we'll see how many tests we can get passing with the code as it is, and we'll work on it from there. Mul div, and let's. Oh, thank you very much. Go away. Oh, it's so cool. That's so cool. Minus 5, 2, 3, multiply 2, 6, 12, divided by 12, 6, 5, 3, gives whole numbers. Oh, I love it. Let's add that to the index, and most likely change you will encounter is how to properly call a function references using an arguments list. Now go to top level, run step 2 of the tests, and let's see how many tests we get passing. Okay. Wow, we actually got a lot passing. Success. -3. Oh, we don't have negative integers. Hey, I think we could do that pretty quick, maybe. Reader HPP. So in the Lexer, if it starts with a negative, then we'll Lex it along with that. Yeah. And we'll put it here too. Oh, but that's not actually right, because you can't have it multiple times. Okay, so I need to rethink this just a touch, just a little bit. I need to do a ++ m index here, I think. Actually, that might be it. That might be the whole thing, because we've already tested the first character. We just want to start on the second character. Yeah. And then in the reader, so that was the tokenizer. In the reader itself, where we have read integer, we're going to say well, how do we do this? I'm going to say if C is a negative, then num times equals -1. Else do this. Maybe. Let's see what happens. -45. Error -45 not found. Well, that didn't work, did it? That did not work. Read integer. Oh, right here. Also need a negative here. -45. Oh, but it's positive. It's positive. Is that because there is no such thing as a -0 integer? Probably. I'm going to say bool negative is false. Say negative is true here. I'm going to say if negative, then num times equals -1. Yeah. Does that work? Does it work? Oh, so excited about this though. Yes. Yes. Run our tests. Input output error. Assertion type function failed. Did I break? Oh, I did. I broke it. So our lexer needs to be smart. If it's just a minus by itself, if it's just a minus by itself, it needs to do something different. It needs to go down to here. How can I how can I do that? How can I do that? I actually kind of want it to fall through. Is that even a thing? How am I going to do that? Hell. I kind of want my lexer. Okay. Let's pull this out into a function. Return tokenize symbol. And then put this here. Right. Instead optional. Nice symbol. This should probably be private, and so let's move this private up. And is this actually optional? I don't know if it is or not. So what? I feel like I'm kind of going off the deep end here. I don't know if this is actually right or not. This kind of feels a little bit wrong, actually. Kind of feels a little wrong. So what are you complaining about? So I think if I get here and I say m index minus start is 1 and view at start is a dash, then I want to return a tokenize symbol, otherwise return the subster. Oh, I really don't know about that. I don't know, but I'm just going to run the test and see what happens. I do need to... My make file is not quite perfect. It doesn't know how to rebuild when the header file changes. So let's do that again. Input output error. Yeah, something's not quite right. Something's not quite right. -45 minus 6 minus 3. I guess it thinks a blank was not found. Okay, I know what the problem is. I think I know what the problem is. If this happens, I need to minus m index and put it back where it was. Does that fix that? No, of course not. Still getting a number. Okay, let's do std cout m index minus, let's see, m index is equal to m index, and start is equal to start. Just want to test my assumptions right here. And we did so good up to this point. Just that last test. Minus by itself. That would be a 1. 1 minus 0 is 1. And view at start. Yep. Should be returning a function. Yep, it sure is. Oh, so it's not the tokenizer. It's not the tokenizer. It's the reader. It's the reader. I have the same problem right here. Let's say if reader.peak dot length is 1, then it's just a minus. Return read atom reader. Return. Else I'll just do like this, read integer. Peak. No number size? I thought it was, oh, value dot length. I don't know. I'm getting tired now. Okay, reader dot peak. I thought that was it. Reader dot peak returns a string view. Oh, that is it. Okay. So if its length is 1, then it's an atom. If it's longer, then go ahead and read the integer. Please, 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 just work. Yes. Minus 45. Boom. Tests pass. Tests don't pass. Tests don't pass. That's just an error. ABC not found. What did you expect me to do with that? Expected me to... This is a good time to do exceptions, and since this video is just about at the max that I want to do, I will save exceptions for the next video, and we'll call this good. I'd say this was a success. I kind of got hung up a little bit on that minus sign. That was a little tricky. I wonder if there was a better way to do that, but it's just kind of weird in our tokenizer that we have to like a negative number versus a bare subtract by a bare dash by itself. You just got to handle it different, and you kind of got to look ahead to do that. So that was the best way I know how to do it. Seems to work. I guess we only have, it's hard to tell because this like blows up and doesn't tell me how many tests are failing. But I think this is a good place to leave it because, I mean, the bulk of what we came here to do is working. It's doing math, and it's apparently getting the right answers. We've got negative numbers and everything else. So I'd say this was a success. It is really cool that these little steps of pulling apart the list and evaluating each piece and treating it as a function call, it's just fantastic. It works really well. And I think this really shows the power of Lisp, how fantastic it is at making a language with list manipulation. So I guess that's it for this video. Thanks for hanging out. Hope to see you in the next one.